Welcome students, welcome to these online sessions of operations research. In this lecture, we are going to study about goal programming. We will introduce a concept of goal programming and integer programming. So let's start. So basically, we will start with the goal programming. We will introduce the concept. Then we'll look into the formulation of goal programming. Same with the integer programming. We will introduce the integer programming. Then we will formulate the integer programming. So what do you mean by goal programming? Now, initially in a linear programming problem, what we look for, we had objective functions to maximize the profit or to minimize the cost for the company, right? What will happen is side by side there are goals for the companies where they are conflicting ones. Conflicting in the sense, let's say for example, the company wants the employees wants the salary rise, at the same time, the company want to cut down on the cost. So these two are the conflicting goals for the company. So what the company wants to do, instead of maximizing the goals, the company try to satisfy these goals. Instead of going through the optimum results, company go through the satisfying, you can say satisfying results. The company tries to find out. So that is what the focus of the goal program is. So here if you see, it has the specific numeric goal for the each objective and then attempts to achieve each goal sequentially up to satisfactory level, but not up to optimum level, right? Now, who introduced it? Chance and Cooper in around 61. They suggested this kind of method for the conflicting resource constraints. You can get this research paper online uh, regarding this goal programming. What are the examples? The first already I have given, the maximizing profit and like increasing the wages. In the same way, increasing the product quality as well as decreasing the product cost. These two are the conflicting goals the companies wants to. Uh, they wants to achieve both the things, but they are conflicting ones. So they can use this goal programming. Now let's introduce a concept called deviational variables. These are frequently used in goal programming problems. Deviational programming, these two variables are introduced in the goal programming modeling, right? Now, what these deviations are, these deviations the company wants to minimize. They are the overachievement or the underachievement for the company, right? So, if you talk about DI minus, that is the underachievement, right? And DI plus, that is the overachievement, not overachieve the goal or not underachieve the goal. Yeah, and definitely these deviations the company will minimize as the objective function. Now, what do you mean by these deviational variables? What they represent is that the extent to which the target goals are not achieved. Okay, whatever the target goal is, the company is, and these are not achieved, right? The companies, these deviational variables represent that, and what the company will do, the company is trying to minimize those deviations, right? And whatever the sum of these deviations are there for the company, they will try to minimize those deviations. And how do they do that? They do based on the relative importance of these deviational variables. Now, what are the steps? The first of all, you will identify the constraints, objective functions, and the decision variables. Just as the linear programming steps, we will identify those. We'll also introduce the deviational variables in the form of overachievement and the underachievement, right? And the same formulations we did in the linear programming, we also follow the same procedure in the goal programming. The difference, only difference is that we also introduce the deviational variable side by side. Clear? Now each constraint we develop equations with the adding of the deviational variables as written here, that is di plus and di minus. Clear? Now what do you mean by these deviational variables? These deviational variables are the possible deviations from the target. What we have achieved as a goal, right? And we will introduce the target value, which is nothing but the right hand side of the constraint. Write the objective function in terms of minimizing a prioritized function of the deviational variables. As you can say, the sum of these deviation variables we will try to minimize. Why? Because that is what the objective function of the company is. Let's look into an example of the goal programming. A manufacturing firm produces two types of products, A and B, right? The profit from A is 100 rupees and for the B is 50 rupees. The goal of the firm is to earn a total profit of exactly 700 rupees in the next week. That is the constraint. That is for the next week. short-term goal. And sales volume from product A and B from is to be 5 and 4. Now formulate as a goal programming problem. So let's start with the model formulation and x1 and x2. Let's start with x1 and x2, which are the number of products A and B to be manufactured. What are the constraints here? The profit goal is 100, x1 plus 50, x2 is equal to 700. That is the profit target goal. Now x1 should be less than equal to 5. That is what here the sales volume was. And for the x2 it is less than equal to 4. That is the sales target goal for the B product. Now we will also introduce the deviational variables D1 plus, that is the profit target overachievement. Plus signs indicates overachievement, minus sign indicates the underachievement, and D2 minus and D3 minus. These two are the underachievement of product A sales and product B sales accordingly, right? Now how do you formulate into the goal programming? We try to minimize this underachievement and overachievement. So D1 minus plus D1 plus D2 minus plus D3 minus. All of these overachievements and underachievements we have to minimize so that company can achieve the target value. Subject to 100x1 plus 50x2 plus D1 minus. So underachievement here, if you see underachievement of profit target, we have to add, right, so that we can achieve the profit, and overachievement we have to deduct here so that we can achieve the target value of 700. Same way x1 plus d2 minus. What is d2 minus? That is underachievement. So when we add the underachievement so that we can achieve the target of 5 for the next week. In the same way, the underachievement has to be added in the third constraint. Here, that is not what the sales target goal is. So based on the profit target goal and these two sales target goals, we can formulate the goal programming problem. So all these variables are greater than equal to 0, as in same as the non-negativity constraints we derived in the linear programming problem. Now we have the constraints available here, equations available here from the inequalities. So now onwards we can easily solve the problem with the help of the simplex method. As always we discussed in the linear programming problem, the same method we will apply here and we can solve the linear programming problem. We can extend this linear programming problem methodology to the goal programming problem as well. Let's look into the integer programming. The new concept, integer programming, as the name indicates, focuses on the extension of the linear programming where you have the integers only as the values of the decision variables. Here, for example, number of trucks to be decided, number of aircrafts to be decided for the company. They cannot be other than the integers. If you get the answer, they cannot be fractional values, right, decimal values, but they have to be integers only. Clear? So in those cases we have two methods, specifically branch and bound methods and graphical methods, to solve the integer programming problems. What are the different types of integer programming problem? First of all, we have pure integer problems where you have the we have only allowed as a decision variables as the pure integers, but you have the mixed integer as well, where some of these fractions values are allowed. Like 0, 1 are the special cases where only as go, no go, or 1 or 0, yes or no kind of situations arises. In that cases, like we can use this 0, 1 integer programming, specifically used in the computer engineering. Let's look into an example to get into the concept of integer programming, where a company, Harrison Electric Company, manufactures chandeliers and ceiling fans. Here the constraints for the manufacturing is given of chandeliers for 2 hours to wire and 6 hours to assembly for the chandeliers. Same for the ceiling, they have 3 hours to wire and 5 hours to assemble. If you look at the production constraints, the capability is 12 hours of wiring and 30 hours for the assembly. That is the constraints for the production. If you talk about the profit derived from the chandeliers and fan, it is $7 and $6. Now, if you look carefully here, the decision variables are integers. Why? Because you cannot have the fractional values of chandeliers or the fans. So definitely this is the problem of the integer programming only. So let's look here that x1 and x2, and sometimes when we get the answer you don't always get the integer values, right? You also sometimes get the decimals or fraction values, which is not allowed. Like here, if we formulate it, x1 is the number of chandeliers and x2 as the number of ceiling fans, then the maximizing the profit will be 7x1 plus 6x2, right? Subject to these two constraints which we already shown in the previous slides. Obviously, x1 and x2 are definitely greater than equal to 0. That is the non-negativity constraints. When we plot this graph, this is the feasible region, right? And we got the optimal linear programming solution as the 3.75 and 1.5, which is not feasible because you cannot have like chandeliers as 3.75 and fan as 1.5, right? So what is the solution here? We can do the enumeration method or rounding off method. Rounding off method will not provide you the answers, right? If you round off x1 to 4 and x2 to 2, right, that is unpractical solution for the company. But if you are x1 equal to 4 and x2 equal to 1, it may not be the optimal feasible integer solution. If you should, the optimal integer solution based on the enumeration method is given here, and the solution based on integer programming problem is coming out to be 5 and 0. 5 numbers of chandeliers and 0 number of ceiling fans, which is giving the maximum profit for the company. But if you do the rounding method, then the solution given here is 4 and 1, which is not the optimal solution based on the integer programming. We will look into some of the examples of integer programming in the forthcoming lectures, right? So how do you solve Komori cutting plane algorithm and how to solve this algorithm, use this algorithm to solve the integer programming problem as well as the goal programming problems as well. So till then, we have in this lecture we have introduced the goal programming problem. We have also seen the example of goal programming, how to formulate the goal programming problem. We also introduced the integer programming, and we also looked into how to formulate the integer programming problem. Forthcoming lecture, we will solve an example based on goal programming and integer programming. Thank you.